Hello everyone, I am Dr. Fawzul Atiq. I am going to give some series of lecture for the course Discrete Mathematics. So in this lecture, I'll start with the first unit, and the name of this unit is the Foundation, Logic and Proof, right? So what will happen in this course, as I mentioned, that we'll start with the unit called the Foundation, Logic and Proof. Then why you should study logic? So it is very much important in mathematical logic reasoning, right? You should have the mathematical, this logic sense, even if you are, again, you are a mathematics student or if you are a computer science student. So a lot of places this proof technique, right, that it will be helpful throughout your mathematics career. Then software system have been developed by constructing some type of proofs automatically. Some all this you will also see that, okay, some kind of proposition you will learn, that is a conditional statement, biconditional statement, right, rules of inference. These are, again, it will be with you throughout your career. So without wasting time, we will start with the main thing. It is called the proposition. So what do you mean by proposition? A proposition is a declarative statement, that is a statement that declares a fact, and which should be either true or false, but not both. Which should be either true or false, but not both. Just a minute, I'll change the color. Yeah, so a proposition is a declarative statement that declares a fact, and that is either true or false. It should not be both. Now, just simplest example is the New Delhi is the capital of India. Now look at this statement. It is declaring a fact that New Delhi is the capital of India, and we all know that it is a true fact, right? So therefore, this statement is a proposition. It's a declarative statement which is a true one. Now look at the next example. SRMAP is in Vizag. Now we know that, okay, for this SRMAP is actually in Amaravati. But this statement is declaring a fact. It says that SRMAP is in Vizag, and which is actually false statement, right? But it's a proposition because it declares a fact and it is always false. Because we know that SRMAP is in Amaravati. Then we have another one, 2 plus 3 equal to 5. Again, it declares a fact, right? And which is a true fact. So therefore, it's a proposition. Now look at this one, 2 plus 2 equal to 6. It is, again, declares a fact and which is a true fact. In this case, it is a false one, but it declares a fact, therefore it's a proposition. Whereas the previous one was also declares a fact, it was a true fact, but this one is declares a fact, but it's a false one. But it is false always, therefore it's a proposition. Now all of you try to understand the logic. All of you try to understand the logic. Now I'm making this statement. Is it a proposition? All of you try to understand the logic. No, it's not a proposition. It's not declaring any fact. It do not have any truth value. It's kind of advice. Correct? Okay. What time it is? Is it a proposition? No, it's not a proposition because it's a kind of a question. It do not have any truth value. Therefore, it's not a proposition. Like this one, read this carefully. Yes, it's not a proposition because it's again kind of advice. It do not declares a fact. It do not have any truth value. Now look at this example. X plus 3 is equal to 5. It is a bit interesting. So it declares a fact that x plus 3 is equal to 5. But although it is declaring a fact, but whether it is a true fact or false fact, is it true, this statement, or false? We don't know. It depends on the value of x. Therefore, for some values of x it is true, but some values of x it is false. So therefore, it is not a proposition. Because if it is a proposition, then it should have a unique truth value, either true or false, but it should not be both. Therefore, it is not a proposition. With the same reason, the last one, x plus y is equal to z, it is again not a proposition because you don't know the values of x, y, and z. Clear? So I hope this is clear. What do you mean by proposition? So proposition should be a declarative statement which should declare a fact and which is either true or false, but it should not be both. It should not be like sometime it is true, sometime it is false. No. I hope it is clear. Okay. So therefore, this one, the whatever we have discussed, it is written here. This is for the sake of completeness. It is written. Now, we will discuss about propositional variable and its truth value. See, in the few previous slides, we have seen a lot of examples, na? That New Delhi is the capital of India, 2 plus 3 equal to 5. So several big statement proposition we had, which are big statement. And in real life, you may have to deal with them and you have to, maybe you will apply them, you will construct new proposition, right? So it is always good idea that if it is a proposition, if it has a truth value, then you always denote each of the proposition by some variable, maybe p, q, r, like this. Usually it represented by small letters. So this kind of variables we called it as propositional variable. And because propositions are either true or false, so this all of the variables will have only two possible values, either true or false. If it is true, then you will say it is t. If the proposition is false, then you will say it is f. Right? So this is called the propositional variable and their truth value. Then compound proposition. So many mathematical statements you will construct by combining one or more number of existing propositions. So with the help of some proposition we have, and then with the help of this proposition, existing proposition, and some logical operations, we will create a new proposition called compound proposition. Now let me give you an example. Suppose New Delhi is the capital of India. Then another proposition we have, New Delhi is located in the northern part of India. So these two individual proposition I had, and now I'm making another statement. New Delhi is the capital of India and New Delhi is located in the northern part of India. So I create a new proposition with the help of two existing proposition and an operation, logical operator called AND operator. Right? So this new one is actually a compound proposition. We will discuss this kind of compound proposition now onwards. So the first and easiest compound proposition is the negation of a proposition. Let P be a proposition, then the negation of P is denoted by this negation of P. So P was initially a proposition, then we create a new proposition called negation of P. You read this as this symbol as negation or not P, and it is the statement that it is not the case that P. So it should be exactly opposite of the case P. Right? And if you have this proposition P and if you have negation P, so because they are not P is the case that it is not the case that P, so if P is true, then your negation P will be false. If P is false, your negation P will be true. Correct? So this one you called is actually a truth table. So this is the truth table of the negation of a proposition. So P and not P. So if P is true, negation P will be false. If P is false, negation P will be true. Clear? These are easy things. Now look at the example. Find the negation of the proposition that Ram's PC runs Linux and express this in simple English. So your first job is what? That suppose this is the proposition P, you have to find out what is negation of P. You have to find out what is negation of P. Now we know that negation P is that it is not the case that P, therefore the negation should be it is not the case that Ram's PC runs Linux. Our answer is done. Right? But you have to make it even in simple sentence. Why you will make this kind of big statement? Ram's PC does not runs Linux. That will be enough. right? So if I write negation of P, it will be Ram's PC does not runs Linux. Then this will be the negation of P. And you can see that if you again negate it, if you again negate it, negation of this one is actually again you will get back to the original P, right? Ram's PC does not runs Linux. So negation of it is Ram's PC runs Linux. Clear? Now, some of you may say that, yeah, so this is the final answer. As we have seen, the Ram's PC does not run Linux. Now, someone say that, okay, negation of this statement is Ram's PC runs Windows. Is it a negation of the statement P? So, someone says Ram's PC runs Windows. Now you think of it whether it is a negation of the original statement or not. See, we have seen that if I have, or we understood that if I have negation P, and if we again negate it, I should get the original proposition P, correct? Now, although if this is the truth, then this will be false. That I understand, okay. But is it the actual negation of the original statement? No. Why? Because if you again negate this one, if you again negate this one, are you getting back to the original statement or not? So you have Ram's PC runs Windows. Negation of it. Are you getting Ram's PC runs Linux? No. So therefore, and why it is no? Because there are several other operating systems. You may have iOS, you may have this Android also now runs, right? Run some PC. So you have several other things. So Ram's PC runs Windows is not exhausting the whole fact, the negation of the actual statement. Therefore, this is not a correct answer. This is not a correct answer. Your correct answer should be Ram's PC does not run Linux. So you should have this kind of question in your mind, and that's why I said it is very, very logical. This course is very, very logical. Everything has its logic. The logics are very easy, but there are some logic. I hope you understand. Okay. Now look at this example. Find the negation of the proposition Bandhana smartphone has at least 32 GB of memory and express this in simple English. So what we will say? So you will say that it is not the case that Bandhana smartphone has at least 32 GB of memory, right? So this, at least you have to think about this portion and you try to negate this statement. Give the negation of this statement. So several students used to answer that, okay, the answer will be Bandhana smartphone has at most 32 GB of memory. This is the final answer in simple English. Bandhana smartphone has at most 32 GB of memory. But it is not exactly correct answer. If I consider the X is the Bandhana smartphone and X is the memory of it, then according to the given statement, if this is the statement P, if this is the statement P, according to the given statement, P says that X must be at least means what? X must be greater than or equal to 32. X must be greater than or equal to 32. Right? And if you are saying that Bandhana smartphone has at least 32 GB of memory, and then its negation is Bandhana smartphone has at most 32 GB of memory, that means what? That means you are saying negation P is X is less than or equal to 32. Now, is it a correct answer? At most means X is less or equal to? No, it is not a correct answer. Why? What is the problem? Problem is there in this equal to sign. Right? So this should not happen. So therefore, the correct answer should be Bandhana smartphone should have. So according to the mathematical definition, X should be exactly negation of it x greater equal to 32 is negation of it should be x is less than 32. So equality you should not consider. And therefore, your actual final answer will be Bandhana's smartphone has less than 32 GB of memory, which should be your exactly negation of it. And again, if you double negate it, you will get back to the original one. Negation of negation P, if you do, you will get back to the original one, right? So therefore, uh, initially, but it is not the case that Bandhana smartphone has at least 32 GB of memory. And final answer will be Bandhana smartphone has less than 32 GB of memory. Because of this logic, right? So please try to understand each and every logic of this course. Very small, easy type of logic, but they are logical and it matters a lot. Clear? Okay. And then finally, we have also learned the this P and not P type of this truth table. This kind of thing you called it as truth table. If P is true, then negation P will be false. If P is false, then negation P will be true. And as I mentioned, we are following this book only. Then I will discuss one few more compound proposition. It is called the conjunction of proposition. So let P and Q, two proposition I have, P and Q. So again, compound proposition is what? We have some existing proposition. With the help of some logical operator, we will create a new proposition. So these two existing P and Q are some existing proposition. And we create a new proposition called P and Q. So this symbol is, you read it as, this symbol, you read it as P and Q, right? This is the and Q, P and Q. And now I am giving some example. Before I'll be discussing about its truth value. I am giving you some example. I am saying that New Delhi is the capital of India. It's one proposition. Another proposition is New Delhi is located in the southern part of India. Then with the help of these two propositions, I am creating a new proposition called New Delhi is the capital of India and New Delhi is located in the southern part of India. Is it a true statement? Definitely not. Why? Because although it's a proposition, it declares some fact, but the second part of is actually false. Therefore, the whole statement becomes false. So this will become false. So what we understood from this example, that if I am taking this AND operator, so P and Q, if I am doing, and it should be true if I have both the existing proposition, like both the involved proposition P and Q both should be true. Otherwise, it will become false. Correct? So therefore, we can make this statement as the conjunction P and Q is true whenever both P and Q are true, and it is false otherwise. Clear? Then if I write the truth table of it, what will happen? P, Q, and P and Q. So you have to consider all possible cases, because P and Q are in proposition. It may be true, it may be false. So we have to take all possible combinations. What will happen? P is true and Q is true. Both can be true. P can be true, Q can be false. This can be false, this can be true, and both of them can be false. And what we understood that P and Q will be true if both the involved propositions are true. So therefore this will be true. But all other cases, one of them is false. This is false. The first one is false. This is also false. Both of them are false. P and Q must be false. So this will be the truth table of P and Q. Clear? Very easy. So understand from the example. So as we discussed, this will be the truth table of the compound conjunction of two propositions P and Q. Then next we have disjunction of proposition. What is that? Let P and Q be proposition, then the disjunction of P and Q, it is denoted by P or Q. So I have two existing proposition P and Q. Then I create a new proposition by this logical operator OR. P or Q. So you read this one as OR operator, P or Q. And again, try to understand the meaning of it. Again, now I'm saying that New Delhi is the capital of India, or New Delhi is located in the southern part of India. Then this statement is true, right? Because you are saying or. One of them, if among the two statement P and Q, if one of them is true, then the whole statement will become true. If both of them are true, definitely it is true. But if you have at least one of them are true, that makes the whole statement to be true. Right? So therefore, the disjunction P or Q is false whenever both P and Q are false. In all other cases, it will be true. Because P or Q will be false. That means both of them, if they are false, then no chance of having true. Therefore, it is false. But in all other possible cases, it is true. So if we have understood this, then what should be the truth table of it? P, Q, P or Q. And we'll again consider all possible cases. T, T, TF, FT, and FF. So these are all possible cases, all possible combinations. And P or Q, now both of them are true. OR operator, this is true. Next one is one of them true will makes it true. This one also true. But here both of them are false. So P or Q must be false. So this will be the truth table of P or Q. Right? So we are about to finish this lecture. But one suggestion to all of you that see this kind of small truth table we are doing, right? P and Q, P or Q, and in the followed lecture also we'll see that few more truth table we'll be doing. But my suggestion is to all of you that please do practice of this small truth table also, because later on you will see that we'll make big truth table where this kind of truth table is everywhere involved. And if you forgot some of the portion, you will have the mistake in the whole table. Right? So please do practice this small truth table, so that later on when you will have a complicated truth table, which are actually not a complicated one. So this kind of things, combinations of that you have to do. So and maybe little bit carefully you have to do that. So please do practice of this. So let me end this lecture up to now. And again, all the content I have taken from the book, Kenneth H. Rosen book. So in the next lecture, we'll be talking a similar kind of compound proposition and their truth table. Right? Thank you very much. I hope you enjoyed. We'll meet in the next lecture.